Welcome back to Smith Coding and Design. This is tutorial 2 of the microARC fixture plate. In the previous tutorial, we went over how to make soft jaws for Op2. In this tutorial, we will go ahead and get our assembly with both operations ready and then go into our setups for CAM and maybe even get into some CAM operations. So the first thing we want to do is go ahead and open up our model that has the vise and our parametric round stock. We are going to go to modify and then go to change parameters. We want to make sure the diameter of our stock is set to 4 inches. And then what we want to do is go ahead and enter the height of our stock. So I measured my stock with a pair of calipers. I'm going to go ahead and enter the height in. Okay, we'll press OK. And so now we have the height of our stock set properly. The next thing we want to do is go ahead and drag in our model. We'll move it up and out of the way. We'll press enter and then we'll move here. We'll press J for joint. We'll grab the middle of the fixture plate and then we'll join it to our stock. Now if it flips like that, all we need to do is come over here and press the flip, and there we go. And now the pins are 1/8 of an inch. So what I want to do is start off by coming down by 1/8 of an inch. And then I want to go down 50 thousandths more, just so that way we can perform a facing operation and get the top nice and flat. So we'll leave this at 155 thousandths and press OK. There we go. So that's it for putting our model inside of our fixed jaw vise. And now what we'll do is we'll assemble both the vise fixture for Op2 and Op1 together. All right, so now what we're going to do is go ahead and make an assembly. In the previous tutorials, I brought the vise models into the assembly and then jointed the model, or what would be our part of the fixture plate there. Instead, I think I'm finding it more efficient to go ahead and put our part in the individual vise setups and then go ahead and drag them into the assembly. So I'm just going to go up here to new design and then I'm going to Control S for save. I'm just going to name this assembly, press OK, and now I'm just going to very simply drag in the individual vise models. So I'm going to start with our Kurt model that has the parametric stock and our fixture plate. Press OK. And I'll zoom out a little bit and I'm going to drag in our vise model with the soft jaws for Op2. And then I'll just go ahead and slide this over and press OK. So there we are. We have our two vise models ready to go ahead and perform our CAM. So that's what we'll do next. I'm just going to go ahead and Control S to save, press OK, and then we're just going to go over here to the manufacturing tab. All right, so now what we need to do is go ahead and create our setups. So I'm going to right click on setups, new setup. And what I want to do is go over to the stock tab and I want to choose from solid. And what we want to do is choose our parametric stock. So what I will do is just expand the model out, and we want to be in our first vise fixture here, and we'll select the parametric stock. Perfect. So then we'll go to the processor tab and we want to give our program a name. So when we generate the G code, it will be something we will remember instead of a number. So what I'm going to do is just call this the microARC fixture Op1. And then we'll go back up to the setup tab. We want to look at our work coordinate system, our WCS. And for this tutorial, we want it to be in the center of our stock, which it is. We want to make sure our axes are pointed in the correct direction, which they are for my Toolpaths. Make sure they're right for your machine. So all that looks good. So now I want to select the model. So we're going to click here and go ahead and select our microARC fixture plate. Perfect. And now we're going to enable the fixture, and we just want to select all of our vise components, so the soft jaws and the rest of the vise. We do not want to select our model or the parametric stock. And then we'll go ahead and press OK. And we will name our setup. So I'm just going to call this op1 and press enter. All right, so that does it for the first setup. Now we need to create another setup. So what I'm going to do is just, again, right click, new setup. And what I want to do now is essentially make the first Vise fixture invisible. So let's minimize it here, make it invisible, and then we want to make the second Vise fixture for op2 visible. And if you notice, sometimes this happens and you can't see the Vise fixture. All you need to do is expand and go ahead and make sure all the components of the Vise are visible. Perfect. And then what we'll do is go to the stock tab again, make sure we have from preceding setup selected, which it is. We'll go again to the post processor tab, we'll give it a name. We'll say microARC fixture op2. And then we'll go back to setup. And what we want to do is go ahead and select the model. So I will select again the microARC fixture, but this one that is in the second Vise setup. Okay. And again for our WCS, we want it to be in the middle of the stock, which is where it is. So that all looks good to me. I will enable fixture, and then I will select the individual components of the Vise. And then I will select OK. Perfect. So now we have both of our setups done. What I will do is, again, we'll name this one op2, and then we can begin actually generating and creating our toolpath. What you see here in op2 is just the bare stock, since we have not yet done anything on op1. But again, this is nice because in Fusion 360 you can toggle between the two setups for op1 and op2 very easily. So that's good news. So now what we'll do is we'll go ahead and go back to op1 and we will start creating our toolpaths. So now we're going to go ahead and set up our first toolpath. So we're going to do a 2D face. So the first thing I'm going to do is just minimize the models drop down and get rid of the sidebar. And then I will go to 2D face, and we're going to select the Tormach Superfly and have it set up for 3-inch diameter. So I'll go ahead and select, go to the 770 tool library and select the Superfly. We're running at 2000 RPM, and we're going to be going 30 inches per minute. That gives us a chip load at right around 15 thousandths, or 15 thousandths exactly. The next thing we want to do is just briefly go through our geometry and our heights tabs. So it's a facing operation. There's not much here in terms of geometry. That's fine. We'll then go to heights. We want to make sure our top height and our model top are correct. So the top height is the stock top. That's correct. We're going to start facing from the top of our stock. This is our first toolpath. The next is the bottom height. So we are going to face from the top of our stock to the top of our model, which is fine. The top of our model will end up being the top of the pins shown on the fixture plate. So all of that looks good to me. We'll then go into passes, and here's where we start changing some of the parameters, and the toolpath becomes slightly more interesting. So for step over, we're going to use 50% the diameter of the tool. So I'm going to use 1.5 inches. We are then going to enable multiple depths, and we are going to take passes 25 thousandths at a time. So that all looks good to me. The next thing we want to do, just to make sure that our tool goes off the edge of the stock, is always come over and select extend before retract. All right, so that all looks good to me. We'll just look over passes one more time just to make sure that we didn't forget anything. Step over looks good. Maximum step down is fine. Okay, so I'll click OK. And now what we'll do is we'll right click and simulate. We'll go ahead and run the simulation, And then what I want to do is sort of stop here on one of the edges, and we'll go to the front view. And again, just so I get a good surface finish, I want to make sure the tool comes all the way off the stock. It does, so that's fine. The Superfly, by the way, excellent tool for facing. It'll give you a damn near perfect surface finish. So if you haven't tried it, I suggest you do. It's well worth the cost. So we'll go ahead and play. And it was 50 thousandths of material on top of our model. We set the depth of cut to 25 thousandths, so we finished that in 2 passes. So that's it for our facing. So what we'll do now is we will come up and create a 2D adaptive toolpath. Sorry, so what I meant to say was 3D adaptive clearing. So we'll check 3D adaptive clearing, and then we are going to go to my tool library from my Tormach, and we are going to use the Gorilla Silverback. This is typically what I use for finishing, but again, I don't have a tool changer. I want to minimize the amount of tools that I'm going to use to save myself time. I typically use the Gorilla Chip Breaker to rough out material, but in this case, there's really not a lot of material to rough out, so I think we're going to be okay with just using the 3/8 inch 3-flute Gorilla Silverback. So that's what I'm going to select. We are running at 7,500 RPM. We are going to go 60 inches per minute, and that gives us almost 3 thousandths per tooth at 2.6 thousandths, so that's fine. Geometry we can skip over because it's a 3D toolpath. Fusion takes the geometry into consideration for us. We'll go to our heights tab. I see some issues here. So again, we faced off the top of our material, so our top height should be the model top because we removed all the material on top of our model. We will go ahead and make the retract height the model top as well. And then we'll go into passes where we have some more interesting parameters. Again, optimal load is arguably one of the most important parameters here. The default of 150 thousandths will stall my Tormach spindle. So what I like to do is keep it at around 10% diameter of the tool. I'm going to use 30 thousandths, which is right around 8%. All right, everything else looks fine here. So stock to leave. We could leave it at 20 thousandths if we wanted. I'm just going to go ahead and make it 10 thousandths. Okay, so that's all good. Linking, the one thing again I like to do here, we're probably not going to do a helical entry, but just to avoid cutting air, we're going to make this 20 thousandths. So if we hover above here, this just shows you that this is where the ramp would start above the stock, and if that's set too high, you just cut air and waste time. So making that 10 or 20 thousandths is a good idea. All right, everything else here looks fine, so I'm going to go ahead and click OK. Now Fusion is taking a minute to compute the toolpath, but already I can see some issues and I don't like it. So you see all these nasty retracts as Fusion 360 sort of roughs the outside of our stock away. So what we'll do is we'll go ahead and right click and simulate just to kind of see what's going on, and then we'll fix it in a minute. So this is a good learning experience, I think. So let's see, let's speed it up a little bit. So we go around the outside, and then we start doing all these retracts to rough out the rest of the material, which I think is ugly and I don't like. So what I'm going to do is go back in and edit the toolpath. And if we go to our heights, instead of selecting the model bottom, I'm going to go to selection, and then I'm going to select the face where our flat here is, and then I'm going to click OK. And this will generate a much better toolpath. And so what we'll end up doing to remove the rest of the material around the outside of the part is we'll use a 2D contour with roughing passes. So we'll go ahead and do that now. We'll go ahead and go to 2D contour, and again we're going to select that same 3/8 inch Gorilla Silverback, 3 flutes. We'll select OK, And because we're going to be roughing and doing a finishing pass, I'm just going to go ahead and leave the feed rate at 30 inches per minute. Our spindle is at 7,500 RPM, and that gives us 1.3 thousandths per tooth, so I'm good there. We'll go to geometry and we will select the bottom contour of our part. Then we'll go to heights again, top height. We're just going to make that our model top. Okay. And now what we'll do is go into the passes tab. And the first thing that I want to do is enable roughing passes. All right. And I want to make the roughing step over 20 thousandths. Sorry about that. And then I want to do 3 roughing passes. And then what I'll do, and you'll notice it's showing up red here, and that's just because our roughing pass is greater than the step over for our finishing pass. So I'm just going to change the finishing step over to 10 thousandths. So now everything looks good. I will go ahead and enable smoothing and feed optimization. And I will go ahead and give it a finishing overlap just in case there is any material or anything, any imperfection left over where I enter into the cut. I can overlap by, let's say, 50 thousandths just to try to avoid, again, any artifacts. Let's go to linking, and then I always just make the lead-in sweep angle 45 degrees. So we'll do that. Everything there looks okay. So now Fusion will generate the toolpath. We'll go ahead and simulate. And so now instead of doing all those nasty retracts with the adaptive clearing, we should just be able to go in here and do a nice smooth 2D contour with the roughing passes enabled. And there we go. We just walk around the part, do the roughing passes, and finish the outside with the same toolpath. So I think that's going to do it for this video tutorial. And now what we'll do is we'll actually see the machining on the Tormach. So thanks for tuning in. Please like and subscribe, and I'll see you guys in the next tutorial. All right, so here we are at the machine. I have my round stock in a set of soft jaws. This is 4-inch round stock, and we're getting ready to use the built-in Tormach probing routines to probe around the stock and find the XY center, and then I will probe the top to find the top of the part, which is where we put our WCS origin. If you don't have a probe, you can always use the corner of the soft jaw as we have done in previous tutorials. You'll notice that I have a new probe stylus with a ruby tip. And so a quick tip there, when you're doing your diameter calibration and path pilot and you have a ring gauge and you're trying to figure out a way to mount it or hold it in your vise. So here are just 3 magnets. I'm going to go ahead and stick that there to my vise, and that's firm, it's not going anywhere, and that's just a quick way to hold your gauge to go ahead and do the diameter calibration. Here's my new 4th axis, my microARC. Right now it's covered in plastic just to keep the chips off of it until I make this plate and put the vise on it, or later maybe I'll 3D print or make some kind of cover just to prevent chips from getting all over it. Okay, so now we start our probing routine. We go into the Rec Circ tab and Path Pilot, and then we click the button to find the XY center of a circular boss, and the probing routine will start probing around the outside of our 4-inch round bar, and then it will stop when it completes the routine and give us our XY 0. Now it does take a few minutes, so bear with me. And what I don't show here is the Z probe. So after this routine finishes, you still need to probe the top of the stock just to set your Z0. So again, it's going to take a few minutes, but bear with me. As soon as the probing routine is finished, we'll go ahead and jump into the machining operations on the Tormach, and we will get to see those. Okay, so we finished probing, and now we're going to perform our facing operation using the Toolpaths Superfly. We're going 30 inches per minute, 25,000th depth of cut, 50% of the diameter of the tool in terms of width of cut, which is 1.5 inches. We're taking it nice and slow in Op 1 simply because we're just finishing the top of our part. In Op 2, you'll see we'll run the Superfly much faster and we'll take a nice deep depth of cut, and you'll see the chips actually fly and sort of hit the enclosure, which is pretty fun to hear. Kind of sounds like popcorn, so that's interesting. We produce nice large chips with the Superfly, but look at that surface finish. It's almost flawless. That's why I love the Superfly. And now we're going to jump into the 3D adaptive clearing using the 3/8 inch Gorilla Silverback, 60 inches per minute, 250 thousandths depth of cut, and 30 thousandths for our optimal load. And again, we are just going through and trying to remove material at a decent rate. Now, this roughing toolpath does take the longest, so you'll just have to sit back and relax as we kind of jump through the individual parts. But nonetheless, I hope you find it interesting, and then we'll get into the contour here in a few minutes. So here's sort of the last part of the 3D adaptive clearing. We're going in and removing the material around where the pins are, and the pins simply slide into the back side of the vise, and then the whole vise gets bolted onto the plate with M6 socket head screws. Alright, so now we finish off with the 2D contour. We're taking the roughing passes as well as the finishing pass using the same 3/8 inch Gorilla Silverback, 30 inches per minute, full depth of cut, and again, the roughing passes are 20 thousandths with a cut, and then the finishing passes 10 thousandths with a cut. So that does it. I hope you enjoyed, and I will see everyone in the next tutorial.